Hi everyone, welcome to practice report number 13. This is an application of the ADC using the MAX10. So in short, it's going to convert any analogic data to digital data, and it's going to be visible here on the 7 display segments. And every time I move the value of the potentiometer, it's going to change the digital volume. So for example, the max value it can go is to 3938, and the minimum volume I think it's around 9. There you go. And the connections are quite simple. The yellow one is for the channel 0 for the ADC, and the white one is I think that was the ground, and the gray one is for the BCC. Hi everyone, welcome to practice report number 13. In this tutorial I'm going to explain really short how can you make the design implementation of an application using the ADC with the MAX10. So firstly, what you want to do is to create a new project. In this case, go to new project wizard. Here what you want to do is to make it on your C disk. In my case, the folder's name is MAX10, so I'm going to select that folder, and then I'm going to put the name of the project. So I'm going to go ahead and put ADC tutorial, or just ADC. What's the name of this project? So you have to put the same name twice, and then you go ahead and apply next. It's going to say that the folder doesn't exist, and if you want to create it, you just have to put yes. Empty project, of course, so you go ahead and just put next. We don't want to add any files, so just go ahead and put next. Here you have to put the device family. In my case it's MAX10, and the package name is okay. The name filter is 10M50DAF484C7G. So go ahead and put this name filter. You have to click on this in order to activate the filter, and you're good to go. You just need to go ahead and apply next. Here, the simulation, you just have to put model SimAltera, and here the simulation has to be VHDL, and apply next for it to open. Now you have to put the command Control N, and you have to put VHDL file, apply OK, and here you can make the code. So firstly, what you want to do is to type library, and you have to use the std logic 1164, the std logic ARITH, and the std logic unsigned. So there you go. Now the next part, you have to make the entity. So you have to type down entity and the name of the entity. In my case, it's entity ADC, and then you have to type is. Now make sure you make the correct indentation there. So just click on your keyboard, the tab key, and then you just have to write port. And here we're gonna make the clock. So I'm going to make here just a short title. Now we have two inputs, the CL key and the RST. One is for the clock and the other one is for the reset. So type down CLK in std logic, just like that. And the same goes for this. So you can go ahead and just copy this right here. And there you go. Now the second part is for the display. So I'm just going to go ahead and put the title there. So display. There you go. And I'm going to go ahead and copy this down like that. And end of component. That's correct. We are on the component of the hex 7 segment. So this is the beginning of the ADC component. So we have to type down ADC, ADC1, and this is the port map. We have the first one that is a clock. This is for the channel 0, the channel 1, channel 2, channel 3, down to channel 7, and of course the reset. And that's the end of the port map. Here we have to make sure that the binary to BCD conversion is correct. So we just need to put binary to BCD instance bin to BCD 12, and this is the port map. So we have bin for channel 0 and BSD to have the value of BCD. And next, we have the 7 segment display process. So it's a process that has a parameter of BCD. Here is the begin. We have the case for BCD 3 down to 0, and is 0, 1, 2, 3 down to 9, default case. When it's not other case, it's going to go to default. And that's everything for the first case. And this is the next one, case BCD 7 down to 4, and this is 15 to 12, 11 down to 8, and behavioral. Make sure you have the correct files in order for this to work. So you need the you need the X7 segment and the binary to BCD. And without those two, your program is not going to compile correctly. So keep that in mind. This is the code for the hexadecimal to 7 segment display. Hexadecimal 7 segment display. And it's really short. We have the entity that has the port X and Y. The X is the input and the Y is the output. And this is the begin. We have 0 to F and an error for other cases. And it's really short. It's not that hard. And this is the second one. This is the binary to BCD. And we have again two inputs, the binary and the binary input and BCD output. And the architecture for this is a little bit more complex. You can go ahead and read all the code here. So then again, you need those two in order for the ADC to work. So okay, I'm going to set this Control S, and then you have to go ahead and type Control L with your keyboard. Yes, and right now it's compiling. You just have to wait a little bit in order for it to compile correctly. So the analysis and synthesis is all good. There you go. So it compiled correctly. Thank you so much for watching this tutorial.